Hello, my fellow YouTubers. This is Roy back again. Well, to kind of explain the Walter Russell double helix vortex, I figure I'd build a little model. And we'll go over this and we'll leave your comments. So what we have here is a cone within a cone. So this is the energy that's screwing by itself and coming out both ends. Now, this is just a visual so you guys can kind of get a grip on what we're trying to accomplish here electronically. So I figure I'd start off by creating a changing magnetic field. I'm using a transistor, using a variable resistor, and 12-volt battery. This is an air core. There's no coil in there. And we'll go over a couple things. Let's go ahead and plug this in. Also, I have a light feeding off this transistor, which is absorbing the back EMF. You can hear inside this coil. You can hear that. And I'm pretty sure if I bring some iron up to it, you'll hear it even more. If not, it'll stop and the light will go off. Let's try a magnet towards it. It's getting louder. So I can put the magnet in the core, but I cannot put just a chunk of iron. It'll kill it. See that? Light went out and it's dead. Sometimes I can just take this and restart it, but that ain't gonna happen. So how do I, this is a bifilar cooler by the way. So how do I get it restarted? So usually I take a magnet and push it through the center. And when you see what just happened there, destroying everything. I just go the opposite way, maybe. All right, lights on. Magnet took off. It's over here. Stay with my Figueroa setup. And now it's back on. We are creating a dipole here. And here's your north side. And here's your south side, okay? So what I'm trying to do here with the Walter Russell double helix is to build this. For what? No end game. There's nothing. I just want to electronically build this. So we're creating 4 dipoles here. And there'll be 2 poles, one polarity, and 2 poles, the other polarity. And I built, well, I'm not done yet, but I built 2 coils, and I need to build 2 more coils that are wound the opposite way. One thing I'm going to show you is, so we have our north on this side, we have our south, okay? And I got just a regular wound coil with LED on it. Now the electromagnetic field here, if it's changing, it should light up this LED. Let's wire loose, I'm pretty sure. LED there. All right. So now when we do that, what we have here, we have an expansion of a dipole, which is what this double helix is gonna do. So we have still north here, south here. This part of this coil becomes, if that's the south, this becomes the north. So we're extending the dipole. And this part becomes the south still. So if I take the compass and put it back over here, we still should be shooting south. And we are, all the way out here. Now let's go ahead and stretch this out a little bit. Now you can see there's a distance, there's a linearity about it. All right, let's see why this ain't going on. That just means the wire's loose. I got one hand. Will this work? Yeah, go figure. Really? Yeah, that's the way it rolls around here at the exploratory lab. There it is. Look, it just lit up. So it's not like, well, there it is. So it's lit on both ends. We're just borrowing off the electromagnetic field. I don't have any instruments hooked up to this yet because this video is not about that. This video is more about just showing a little model visually how this electromagnetic field is going to have to go within itself. So basically, we would start, the center would be a coil, okay? So this representing a coil. And this coil will be rotating its fields, okay? Just like this coil is rotating its fields. And then that means that when this is a positive, this side will be the negative. It'll sort of be like the NST in a sense, where it's flopping, because there will be two transistors here. Back on. So it's about expanding the dipole. And what'll happen in the middle between the two, there'll be something, I just want to call it a node, meaning that there's a null point. There's the lowest pressure. So in that lowest pressure, it would be the wider outside parts of this apparatus, and the inner two parts where you see the highest pressure is right creating like a dipole, like right here. So it'd be one pole here, and it'd be another pole here, and a lot of pressure, only because of that side there is your high pressure and the wide part is your low pressure. A lot of stuff. I just wanted to show you guys. Interesting. Got this magnetic film, which is cool. And I'm thinking about the magnetic film. You can see the field lines. Let's see what one of these show. So you can see the field lines go around the whole outside edge. Pretty cool stuff. Let's see if we can see the field lines here. I don't think you guys can see it, but I can see it. It's around this whole outside edge there. All right, guys, leave your comments. Peace out.